Good morning. In our previous experiment, we have seen how to estimate a phase, that is redox reaction, by measuring the potential. So today we are going to see how to determine the end point of mixture of acids. The same experiment can be done by our classical volumetric estimation. So most of you have done, you estimated the acid using NaOH, using phenolphthalein indicator, right? No, plus 1 or plus 2. Used to take NaOH in the burette, HCl or acetic acid in the beaker, conical flask, add phenolphthalein indicator. So kind of titrate until you get pale pink color, right? So once you get the pale pink color, you note down the volume of NaOH run down, and later find out the strength of HCl and the amount of HCl present in the given sample. The same experiment can be done without using without using indicator. How? By measuring the conductance. What do you mean by conductance? Conductance, the first thing which comes in our mind is reciprocal of resistance. So resistance means the resistance offered to the flow of electrons, right? But that is wrong. That is with respect, of course it's 100% true, but it is with respect to the solids. But here we are measuring the conductance of the reaction. So conductance of the reaction means, well, I'll discuss later, but the entire experiment depends upon the Ohm's law. So what does Ohm's law state? The Ohm's law states that the current flowing through a conductor is directly proportional to voltage and inversely proportional to resistance. So this is the main principle behind your conductometric estimation. And so I was discussing, right, what is resistance here? Resistance, as soon as we tell conductance, the first thing says is reciprocal of resistance. That is true with respect to your solids. But here we are measuring the conductance of solution. So solution, it is completely different. How? So we are measuring conductance. Conductance here means mobility. So mobility of ions. So here we have n number of ions. We have Na plus ions, OH minus ions, H plus ions, CH3COO minus ions, right? So each and every ion will have different mobility. So conductance is directly proportional to mobility of ions. Higher the mobility of ions, higher will be the conductance. Okay. So as it firstly it is told, conductance is directly proportional to mobility of ions. If you have n number of ions, each and every ion will have a specific, a different mobility. So depending upon the mobility, conductance will vary. Conductance is directly proportional to the mobility of ion. That is the first thing. Second thing is, conductance is directly proportional to the concentration of higher mobile ion. Even though you have 1000 ions, okay, conductance will always depend upon the concentration of higher mobile ion. If the concentration of higher mobile ion is high, then conductance will be high. And if the concentration of higher mobile ion is low, then conductance is low. So these three things are very, very important when we discuss about conductometric estimation. So here we are going to measure specific conductance in this conductometric estimation. We have three types of conductance. There is molar conductance, specific conductance, equivalence conductance. What is specific conductance? So when we have a conductivity cell. In the conductivity cells, we have two platinized foils. So the two platinized foils are sealed and placed 1 centimeter apart. Okay, and this area of this is also 1 centimeter. Okay, so the conductance measured in between this is called as specific conductance. Okay, so platinized foils of 1 centimeter area placed. The electrodes placed 1 centimeter apart, and the conductance measured, the solution of the conductance measured in between these two electrodes is called as what? Specific conductance. So let us see how to estimate the acid mixture by measuring the conductance. So here you have a conductivity meter, as you've seen here. We're going to dip the conductivity cell. We're going to connect it to the conductivity meter. So we're going to add NaOH in the increments of 0.5 ml. After every addition of 0.5 ml of NaOH, we're going to measure the conductance. As we have discussed, it is a mixture of acids. So mixture of acids means one strong acid, other one is weak acid. When you have mixture of acid, so when you add a strong base to the acid mixture, Usually the stronger acid will react first and get neutralized, and later the weaker acid. So what do you mean by strong acid? The acid which completely neutralizes the into respective ions is called strong acid, and the weak acid which will not completely neutralize is called as weak acid, right? So which will be in equilibrium, reactant and product will be in equilibrium with each other is called as weak acid. Strong acid is one which completely neutralizes into respective ions. It has a irreversible reaction, whereas your weak acid, which does not dissociate completely into respect to ions as weak acid. When you add NaOH from the burette, so what acids we are taking here? We are taking HCl, a strong acid, acetic acid, a weak acid. When you add NaH from the burette to beaker, what will happen? HCl starts neutralizing. So HCl gives you NaCl and water. So H plus ions will be slowly replaced by Na plus ion. That is, high mobile H plus ion will be replaced by slow mobile Na plus ion. So initially when you dip the conductivity cell into the beaker, so the conductance depend upon high mobile ion. What is the high mobile ion here? H plus ion, right? So when you add NaOH, what happens? H plus ion concentration decreases. Therefore, conductance also will decrease. So once the entire H plus will get neutralized, so now what happens? The acetic acid will come into existence. When the acetic acid comes into existence, acetic acid starts neutralizing. So acetic acid gives sodium acetate and water. So even now conductance depends upon sodium acetate and not acetic acid. Acetic acid is a weak acid, right? So sodium acetate. So here CH3COO minus and Na plus. So now the conductance depends upon Na plus and acetate ion. So the mobility of acetate ion is greater than Na plus ion. As more and more your acetic acid gets neutralized, the concentration of acetate ion will increase. Therefore, mobility of acetate ion is greater, their conductance is also greater. Therefore, our conductance will increase. Once both HCl and acetic acid is neutralized, what happens? Now the conductance will depend upon OH minus ions, because the mobility of OH minus ion is greater than Na plus. So when you add NaOH from the burette to the beaker, doesn't have HCl or acetic acid. So what will happen? The NaOH will remain as Na plus and OH minus. When we compare the mobility of OH minus and Na plus, mobility of OH minus is greater. Therefore, conductance depends upon the OH minus ion. As the concentration of OH minus ion increases, conductance also will increase. Therefore, we get three curves. So what are those curves? We'll see. So initially you can see the first curve. It is due to decrease in conductance, that is by HCl. The next curve is because of acetic acid, and the third rapid increase in conductance is due to OH minus ion. So we're going to extrapolate that. Okay. So from the point of interception, we're going to draw a perpendicular to the x-axis. V1 is volume of NaOH required to neutralize HCl. V2 is volume of NaOH required to neutralize only acetic acid. V2 minus V1 is volume of NaOH required to neutralize only acetic acid. V2 is volume of NaOH required to neutralize both the acids. So the calculations is as shown here. So we're going to first determine the normality of HCl. So normality of NaOH is 1 normal. Volume of NaOH is V1, this from the graph. Volume of HCl is 50. So normality of HCl is determined. We're going to multiply it by the equivalent weight of HCl. That gives weight of HCl present. So similarly, we're going to calculate the normality of acetic acid. So normality of NaOH is 1, it is known. Volume of NaOH to neutralize acetic acid is V2 minus V1 divided by 50. By that we get normality of acetic acid. So in order to find out the amount of acetic acid present, we're going to multiply it by the equivalent weight of acetic acid, that is 60. By that we get the amount of acetic acid present in the given sample per dm cube. So similar calculation is done. So later, what are the advantages of this connectometric estimation? Mixture of acids can be titrated accurately. So it is colored solutions, weak acids, everything can be done accurately. So this cannot be done in our classical volumetric estimation, where it requires more indicators. So for calculations, for demonstration, tabulation, calculation, please click the following link. In the below link, you can see the demonstration of the experiment, how the experiment is done. So don't forget to click the below link. Thank you.